You are holding the most complex object in the known universe. Not in your hands, in your head. Right now, as you listen to these words, approximately 86 billion neurons inside your skull are firing electrical signals to each other across 100 trillion connections. Every thought you have ever had, every memory you have ever made, every dream, every fear, every moment of joy or grief or wonder. All of it happens inside 3 pounds of soft gray tissue sitting in the darkness of your skull. No telescope has ever found anything more complex. No computer has ever come close to replicating it. No scientist fully understands it. And it is yours. It is you. Today we go inside. The numbers that change everything. Before we talk about what the brain does, we need to talk about what it is. Because the numbers alone are enough to stop you cold. 86 billion neurons. If you counted 1 neuron per second without stopping, it would take you 2,700 years to count them all. Each neuron connects to other neurons through structures called synapses. A single neuron can have up to 10,000 synaptic connections. The total number of synaptic connections in a single human brain is estimated at 100 trillion. 100 trillion. That is more connections than there are stars in 1,000 Milky Way galaxies. The brain processes information at speeds that modern computers can only dream of matching in parallel. It operates on approximately 20 watts of power, less than a dim light bulb. Yet it outperforms the most powerful supercomputers ever built at the tasks that matter most: pattern recognition, emotional judgment, creative thinking, and understanding context. The brain is 73% water. It contains no pain receptors. It cannot feel pain itself, which is why brain surgery can be performed on conscious patients. It generates enough electrical activity to power a small LED light, and it never truly turns off. Even in the deepest sleep, it remains extraordinarily active. This is what you carry with you every moment of every day. A universe inside your skull. The brain did not arrive fully formed. It is built in layers, each layer representing a different stage of evolutionary history, stacked on top of each other over hundreds of millions of years. The deepest layer is the brainstem. This is the oldest part of the brain in evolutionary terms, sometimes called the reptilian brain. It controls the functions you never think about because you never need to. Breathing, heart rate, blood pressure, sleep cycles, basic survival reflexes. The brainstem keeps you alive while the rest of your brain does everything else. Damage the brainstem severely and nothing else matters. Above the brainstem sits the cerebellum. This is where coordination and movement are managed. The cerebellum contains more neurons than the rest of the brain combined. Approximately 69 billion of the brain's 86 billion neurons are packed into this one relatively small structure. Every time you reach for a glass of water, type on a keyboard, or catch a ball thrown at you, the cerebellum is orchestrating the extraordinary precision of movement that you take completely for granted. Above that sits the limbic system. This is the emotional brain, the part we share with all mammals. The amygdala, two almond-shaped clusters deep in the brain, processes fear, anger, and emotional memory. The hippocampus, named for its resemblance to a seahorse, is the gateway to long-term memory. Every experience you want to remember must pass through the hippocampus to be stored permanently. Damage the hippocampus, and you lose the ability to form new memories, while keeping all your old ones perfectly intact. And wrapping around all of it, like a thick, wrinkled blanket, is the cerebral cortex. This is the newest part of the brain in evolutionary terms. It is what makes us human. The cortex is where conscious thought happens, where language lives, where planning and reasoning and creativity and self-awareness emerge. It is so large relative to the size of our skull that it has been forced to fold in on itself, creating the wrinkled appearance we associate with brain images. If you unfolded the human cortex and spread it flat, it would cover an area of approximately 2.5 square feet. Four layers of evolutionary history, each one essential, each one building on what came before, together creating something that is more than the sum of its parts. Consciousness, the hardest problem in science. Here is the question that has defeated every philosopher and scientist who has seriously attempted to answer it. How does the brain create consciousness? You are conscious right now. You are aware that you exist. You are experiencing this moment, the sound of these words, the thoughts they trigger, the feelings they produce. That experience, that felt quality of being alive and aware, is called consciousness. And nobody knows how the brain does it. This is not false modesty. This is not a gap that will be filled in by a few more years of research. This is what philosopher David Chalmers called the hard problem of consciousness, and it is considered by many scientists and philosophers to be the deepest unsolved problem in all of science. We know which brain regions are active during conscious experience. We can measure the electrical activity. We can map the neural correlates of awareness. But knowing which neurons fire when you see the color red tells us nothing about why you experience redness, why there is something it feels like to be you, why the physical activity of neurons produces subjective experience at all. Some scientists believe consciousness is an emergent property of complex information processing, that when a system becomes complex enough, experience simply arises from the computation. Others believe there is something fundamentally non-physical about consciousness that cannot be explained by neuroscience alone. Some believe consciousness is a fundamental property of the universe itself, present in everything to varying degrees. None of these positions has been proven. None has been disproven. The most complex object in the universe does not yet understand itself. And that fact, that you are a mystery to yourself, is perhaps the most extraordinary thing about you. Memory, how the past lives inside you. Every memory you have is a physical structure in your brain. When you experience something, neurons fire together in a specific pattern. If the experience is repeated, or if it is emotionally significant, those neurons strengthen their connections through a process called long-term potentiation. The connection becomes easier to activate. The memory becomes more accessible. This is what Hebb's rule describes. Neurons that fire together wire together. Memory is not stored in a single place. It is distributed across networks of connected neurons. A memory of your first day at school involves neurons in your visual cortex storing what you saw, neurons in your auditory cortex storing what you heard, neurons in your hippocampus binding them together, neurons in your amygdala storing the emotional tone, and neurons in your prefrontal cortex providing the narrative context. When you remember that day, all of those networks reactivate simultaneously. The memory feels unified and complete, but it is actually a reconstruction, assembled from distributed pieces every time you access it. And here is the unsettling truth about memory. Every time you remember something, you change it slightly. The act of recall involves reassembling the memory, and that reassembly is influenced by your current emotional state, your current knowledge, and the context in which you are remembering. The memory that gets stored again after recall is subtly different from the one that was retrieved. Your memories are not recordings. They are stories you tell yourself. And every time you tell them, you rewrite them slightly. The brain can store an almost unlimited amount of information in long-term memory. Researchers estimate the storage capacity of the human brain at approximately 2.5 petabytes, equivalent to 3 million hours of television. You will never run out of space, but the brain is selective about what it stores. Emotionally significant events are stored more strongly and more durably than neutral ones. This is why you remember your wedding day more clearly than what you had for lunch 3 Tuesdays ago. The amygdala tags emotional experiences as important and signals the hippocampus to store them with priority. Evolution designed your memory not to record everything, but to remember what matters for survival. And love, fear, joy, and grief matter more for survival than Tuesday's lunch. Sleep, when the brain does its most important work. For most of human history, sleep was considered a passive state. The body resting, the brain shutting down. Wasted time. We now know this is almost completely wrong. Sleep is not the absence of brain activity. It is a different kind of brain activity, and it may be the most important thing your brain does. During sleep, the brain cycles through several distinct stages. In light sleep, the brain replays the experiences of the day, consolidating memories, deciding what to keep and what to discard, transferring information from the hippocampus to long-term cortical storage. In deep sleep, slow-wave sleep, the glymphatic system activates. This is the brain's waste removal system. Cerebrospinal fluid is pumped through channels in the brain, flushing out the metabolic waste products that accumulate during waking hours, including amyloid beta and tau proteins, the substances that accumulate in Alzheimer's disease. The brain cleans itself during sleep. Miss enough sleep, and the waste builds up. Over years and decades, that buildup may contribute to neurodegeneration. In REM sleep, rapid eye movement sleep, the brain becomes almost as active as it is when fully awake. This is when most dreaming occurs. The body is paralyzed, a protective mechanism to prevent you from acting out your dreams. But the brain is running complex simulations, processing emotional experiences, making unexpected connections between ideas, and consolidating procedural memories, the memories of how to do things rather than what happened. Many of the greatest creative breakthroughs in history have come from dreams or from the hypnagogic state between waking and sleep. Paul McCartney heard the melody of yesterday in a dream. Dmitri Mendeleev saw the periodic table arranged in his sleep. The structure of benzene came to August Kekulé in a dream of a snake eating its own tail. The sleeping brain is not resting. It is doing the work that the waking brain cannot, making connections that linear conscious thought would never find. Emotion, the system that runs everything. We tend to think of emotion and reason as opposites. That good decisions come from thinking clearly and suppressing feeling. That the emotional brain and the rational brain are in constant conflict, and the rational brain should win. Modern neuroscience has completely dismantled this idea. Neuroscientist Antonio Damasio studied patients with damage to the prefrontal cortex, the region involved in both emotion and rational decision-making. These patients had completely intact intelligence. Their memory was perfect. Their reasoning was intact. Their knowledge was unaffected. But their emotional responses were severely diminished. They could not feel the normal emotional responses to situations. And what happened to their decision-making? It collapsed. These patients could not make simple decisions. Choosing what to have for lunch took hours. Managing their personal finances became impossible. Their lives fell apart, not because they were less intelligent, but because they could not feel the emotional signals that normally guide choice. Emotion is not the enemy of reason. It is the foundation of reason. Without emotional valence, without the feeling that some outcomes matter more than others, rational calculation becomes meaningless. You can reason perfectly and still have no basis for choosing one option over another. The brain did not evolve reason to override emotion. It evolved emotion and reason to work together, with emotion providing the goals and reason providing the path to achieve them. The plastic brain, rewiring itself throughout life. For most of the 20th century, scientists believed that the adult brain was fixed, that after childhood, the brain structure was essentially set, that neurons could die but not be replaced, that the connections between neurons were largely permanent. This belief was wrong. The brain is plastic, not plastic like a material, plastic like flexible. Throughout your entire life, your brain is constantly rewiring itself in response to your experience. New synaptic connections form. Old ones are pruned away. New neurons are born in certain regions, a process called neurogenesis, even in adult brains. The brain you have today is physically different from the brain you had 10 years ago, and the brain you will have in 10 years will be different again. Every experience changes your brain. Every skill you learn physically rewires the neural circuits involved. Every habit you form strengthens specific pathways. Every thought you repeatedly think makes that pattern of neural firing easier to activate next time. London taxi drivers who spend years memorizing the complex street layout of the city develop measurably larger hippocampi than non-taxi drivers. The physical structure of their brain changes in response to the demands placed on it. Musicians who practice for thousands of hours develop expanded representations of their instrument in the motor and somatosensory cortex. The brain literally grows more hardware for the skills it uses most. Meditators who practice mindfulness consistently for years show measurable thickening of the prefrontal cortex and changes in the amygdala that correspond with better emotional regulation. Mental practice physically changes the brain. This is the most empowering fact in neuroscience. Your brain is not fixed. It is not determined. Every choice you make about how you spend your time and attention is a choice about who you are becoming. At the level of physical brain structure, you are sculpting your own brain. Every single day, language, the ability that changed everything. Of all the things the human brain can do, language may be the most extraordinary. Not just communication. Many animals communicate, but language. The ability to take the infinite complexity of experience and compress it into a string of arbitrary sounds or symbols that another brain can decode and reconstruct into something approaching the original experience. Language allows us to share not just information, but perspective, not just facts, but feelings, not just what happened, but what it meant. And it allows us to do this across time. A book written 3,000 years ago can place thoughts directly into a modern brain as vividly as a conversation happening right now. The brain regions involved in language were identified in the 19th century. Broca's area in the left frontal lobe, responsible for producing speech, and Wernicke's area in the left temporal lobe, responsible for understanding it. But modern neuroscience has revealed that language is far more distributed across the brain than these two regions suggest. Understanding a sentence involves visual cortex, auditory cortex, motor cortex, emotional processing centers, memory systems, and prefrontal reasoning circuits, all working together simultaneously. When you read the word lemon, your taste cortex activates slightly. When you read about running, your motor cortex activates. Language does not just describe experience. It partially recreates it. The words you use shape the thoughts you can think. Languages that have more words for different types of snow allow their speakers to perceive distinctions in snowfall that speakers of other languages literally cannot see. The structure of language shapes the structure of thought, and the human capacity for language did something that no other cognitive ability has done. It allowed the accumulation of knowledge across generations. One human lifetime of learning and discovery could be passed forward to the next generation, and the next, and the next, building not just on individual experience, but on the collective experience of thousands of years of human minds. This is why human civilization accelerated so rapidly compared to any other species. Not because individual human brains are so much smarter than other animals, but because human brains connected by language create something that transcends any individual, a collective intelligence that grows and compounds across. When the brain breaks, lessons from damage and disease. Much of what we know about the brain has been learned from cases where something went wrong. Phineas Gage is the most famous case in the history of neuroscience. In 1848, a railway construction worker in Vermont had a 13-pound iron rod driven through his skull by an accidental explosion. The rod entered below his left cheekbone and exited through the top of his head, passing through his prefrontal cortex. Gage survived. His intelligence, memory, and language were intact, but his personality was destroyed. The previously responsible, well-liked foreman became impulsive, profane, unreliable, and unable to make plans or keep commitments. His friends said he was no longer Gage. The same accident that left his intellect intact had destroyed his ability to be himself. The lesson: that personality, social behavior, and moral judgment are functions of specific brain regions, was revolutionary. Before Gage, most people believed personality resided in the soul. After Gage, science began to understand that who you are is a function of your prefrontal cortex. Alzheimer's disease attacks the hippocampus first, destroying the ability to form new memories while leaving old ones temporarily intact. Patients in early Alzheimer's can remember their childhood with extraordinary clarity while being unable to remember what happened 5 minutes ago. The disease then spreads to the cortex, destroying the stored memories too, erasing a life backwards. Stroke, when a blood vessel in the brain is blocked or bursts, can produce extraordinarily specific deficits depending on exactly which region is affected. Damage to one small region can eliminate the ability to recognize faces while leaving the ability to recognize objects perfectly intact. Damage to another region can eliminate the ability to read while leaving writing completely unaffected. The specificity of these deficits has given neuroscientists a detailed map of which regions serve which functions. And depression, the most common brain disease in the world, is now understood not as a character weakness or a response to circumstances alone, but as a change in the physical structure and chemistry of the brain. The prefrontal cortex becomes less active. The amygdala becomes hyperreactive. The hippocampus can actually shrink. Depression is a brain disease, and understanding it as such, rather than as a failure of willpower, is one of the most important shifts in modern medicine. The future of the brain. We are standing at the beginning of what many scientists believe will be the most important century in the history of neuroscience. Brain-computer interfaces are moving from science fiction to clinical reality. Neuralink and other companies are developing implants that allow paralyzed patients to control computers and robotic limbs with their thoughts alone. In early trials, patients who have been unable to communicate for years have typed messages by imagining the movements involved. Artificial intelligence trained on brain activity patterns is beginning to decode thoughts, translating the patterns of neural activity into words and images with increasing accuracy. In 2023, researchers at the University of Texas used an AI model to reconstruct continuous speech from brain scans with enough accuracy to recover the meaning of what people were thinking about. We are approaching, slowly, imperfectly, with enormous remaining challenges, the ability to read minds. On the other side of that same technology is the possibility of writing to the brain, of directly influencing neural activity to treat depression, PTSD, addiction, and chronic pain with a precision that current drugs cannot approach. We are also beginning to understand aging in the brain in ways that suggest it may be partially reversible. The glymphatic system discoveries suggest that optimizing sleep could slow or prevent neurodegenerative disease. Studies of centenarians, people who live past 100 with intact cognitive function, are revealing the specific genetic and lifestyle factors that protect the brain through extreme age. And the question that haunts the entire field, the question of consciousness, of subjective experience, of what it actually feels like to be you, remains open. Some researchers believe we are decades away from a satisfying answer. Others believe we will never fully answer it. But we are asking it more precisely than ever before. And the brain, the object doing the asking, is slowly, painstakingly, beginning to understand itself. 3 pounds, 20 watts, 86 billion neurons, 100 trillion connections. That is what you are. That is what is reading these words right now. That is what is experiencing this moment. The sound, the meaning, the feeling of understanding something new. The universe is 13.8 billion years old. It spans 93 billion light years. It contains more than 2 trillion galaxies. And in all of that, in all the vastness and age and incomprehensible scale of everything that exists, the most complex thing we have ever found is a soft gray organ that weighs about as much as a large orange and fits in the palm of your hand. Your brain does not just experience the universe, it constructs it. Everything you have ever seen, heard, touched, tasted, or felt, every experience you have ever had, is a model created by your brain, not the universe itself, a representation of it, the most sophisticated representation in the known cosmos. And somewhere inside that representation, in the interplay of electricity and chemistry and structure that we are only beginning to understand, is you, aware, thinking, feeling, wondering. The universe became conscious. It did it here, in you, right now. And that, of everything science has ever discovered, may be the most extraordinary fact of all.